Hi, my name's Nicholas Neitzel. I'm a student in CSCI 5448, which is Object-Oriented Design and Analysis at the University of Colorado Boulder. This presentation is going to discuss a couple of session state patterns. And what session state patterns are design patterns that focus on maintaining a session when a client is using a server or database. So the first pattern we're going to discuss is the abstract session pattern. And the goals of the abstract session pattern are to maintain a session while a client is interacting with a server and a database. And it deals with object-oriented frameworks that are structured in terms of relationships between clients and servers, where an object services are invoked by client objects through the operation of its interface. A common design requirement is for a server object to maintain state for each client that it is serving. And we can usually do this by returning handles or untyped pointers to the client. So the motivation. So why would we use the abstract session design pattern? So it allows objects to maintain a per-client state with full type safety and no loss of efficiency. And just for reference, the abstract session pattern is also known as the server access point context or service handler. So object interactions are defined in terms of an abstract interface, which increase reusability and extensibility of the framework because the set of client and server types that can be used together is not bounded and can easily be extended by framework users. Although client objects are defined in terms of abstract interfaces, per-client state cannot be stored in the client objects themselves because different server implementations will have to store different information. So the session pattern imposes a three-phase protocol on the interactions between the client and the server. Clients make an initial request call to the server when they begin to use its services. The server responds by allocating a per-client data structure for the new client and returns an identifier of that data structure to the client. The client then passes the identifier it received as an argument to subsequent operations on the server. The server uses that identifier to find the per-client information it holds about the caller. When the client has finished using the server, it makes a final release call to the server, passing in the identifier that the server uses to find and deallocate the appropriate per-client data structure. So the session pattern involves the following forces: per-client state, efficiency, and safety. Per-client state is that the server object must be able to store the state about each client that is using its services. Efficiency is invocation of service operations should involve minimal runtime overhead, or they should be efficient, smart with their resources. And safety, we want to catch the use of incorrect session identifiers. Hopefully we can catch these at compile time, but we would like to avoid these at any point. So we have two ways of mapping identifiers to the data structures that store per-client state. We have untyped pointers and handles. Untyped pointers are identifiers that the server object initializes to point to an implementation-specific data structure and cast the appropriate type on each such invocation. Handles are usually identifiers of simple types, such as integers, for example, or a string. The server uses a private associative container to map between identifiers and implementation-specific data structures and must perform a lookup each time a client makes a request. So you could think about a hash map as a way where you would store a handle with a session. Now, when you choose between these two methods, you are essentially choosing between safety and runtime. Untyped pointers are efficient, but if you pass an incorrect pointer to a server, this could cause the program memory to be corrupted, or it could crash completely. If you use handles as indices to an associative container like the hash map mentioned earlier, it prevents incorrect identifiers to be used at runtime, but the cost of the safety is that it slows down operations because invocations are made each time you do a lookup. So if we think about the implementation, we have a protocol service object. Rather than providing client with a handle to be passed as an argument to the operation of its abstract interface, this creates an intermediate session object and returns a pointer to the session of the session object to the client. The session object encapsulates the state information for the client that owns the session. So we'll use abstract pattern for two big situations. The first one is when interactions between server objects and client objects are defined in terms of abstract interfaces. The other scenario is when server objects must maintain state for each client that makes use of their services. So if you look at this use case diagram, these are the four big participants in this abstract interface. So we have the client, the service, and then the service of a session type, and then that inherits from the abstract session. So the service class is just classes of service objects that are created that maintain sessions that are bound to them. And then the abstract session is the interface through which clients bound to a server make use of during their session. And then the service X of type session stores information about clients that are bound to them. Clients invoke the abstract session interfaces of these objects to interact with the server objects to which they are bound. And then the client here is the person trying to access whatever server or database. Now, if we look at the sequence diagram, we can see how a collaboration would take place during a typical use of this design pattern. So a client object wants to use a server object, and it requests a session from the server. The server object creates a session object, which obviously conforms to the abstract session interface, and initializes the session with the information about the client. It then returns a pointer with the specific session information back to the client. The client uses the service provided by the server object by invoking the operation of its session's abstract session interface. The session object cooperates with the server object to complete the invocation. The server object uses information stored in the session object to process requests from its clients and can update the per client information when events occur behind the scenes that relate to the client. And then when a client object has finished using the service provided by the server object, it calls the release operation of its session. Forcing the clients to release sessions by calling this method allows the service to hide the way it allocates the session object from its clients. There are multiple ways that a service could allocate sessions. One possible method is using the heap, in which case the release operation would free the session object. Or you could store it in a fixed number of sessions in an array, in which case the release would update a record in the service object of the sessions that were unused and could be handed out to new clients. So some of the advantages of the abstract session pattern. primarily type safety. Interactions between clients and sessions and between sessions and servers are completely type safe. This reduces the likelihood of obscure errors. Making the code easier to debug and maintain. Performance. The interactions between clients and sessions are as fast or faster than those using unsafe methods, such as untyped pointers or handles. Flexibility. The use of abstract interfaces and encapsulation of per-client state within each server class reduces coupling between client and server classes. A client can use any server that creates sessions that implement the abstract session interface. Extensibility. This pattern makes it easy to add server classes to the system. Such extensions do not require existing client and server classes to change. So now we'll talk about some of the disadvantages. One big one is dangling pointers. We could run into a situation where a session is referenced and used after it has been released. Another disadvantage is distribution. It can be difficult to pass a session object from the server to the client if the client and server exist in different address spaces. When creating a session, the server must send information to the client to allow the client to create a proxy session in its local address space. And then we could run into a situation with multiple languages. If we're trying to call the abstract session from another language, especially non-object-oriented languages, this could be a problem. The solution for this would be writing an adapter layer that hides session objects behind a set of procedures callable from the other languages, but many of these languages use unsafe implementations of the session pattern to identify session objects. So, implementing the abstract session pattern. When we use the heap, we're allocating and deallocating memory from the heap is an expensive operation. Forcing clients to discard sessions via the release method and the abstract session interface, rather than an explicit deallocation of the session object, gives server objects more flexibility in the allocation of session objects. For instance, if the server allocated the session from the heap, the release operation would delete the session object. However, a server might pre-allocate sessions in a cache. When a client invokes the release operation of a session, it need only mark that the session is unused rather than perform a heap deallocation. If a server object does not need to store any information about its clients, it can implement the abstract session interface itself, perhaps using private inheritance. In this case, the release operation would do nothing. And then there's object finalization. In a language with automatic garbage collection, Java is a big one. In object finalization, the act of releasing a session can be made synonymous with releasing the last reference to the session object. The functionality of releasing a session can be performed by the finalization method of the session object and will be called automatically by the garbage collector, once again Java. And if we're working in Java, we can make use of outer and inner classes. We can simplify this by using inner classes. So if we think back to the concrete service class, this would be implemented using an outer class, and then the concrete session classes would be defined as inner classes. The inner class would be associated with an instance of the outer class in which it is defined and can refer directly to the fields and methods of that instance. Thus, inner classes remove the need for an explicit delegation from session to service and reduce the possibility of programming errors. Defining server interfaces. When the clients are always bound to a server by some third party that knows the complete type of all servers it is using, then server objects do not need to conform to an abstract interface. However, in some systems, clients will bind themselves to servers by finding a suitable server object in something like a trader or namespace, and then request a session from it. In this case, servers will need to conform to some abstract interface that can be used polymorphically. So some popular or some known uses of this pattern appear in Microsoft's Object Linking and Embedding Framework, and then Java's Abstract Windowing Toolkit. I'll talk more about Java's Abstract Windowing Toolkit. So the graphics interface provides a common interface for drawing graphics on a variety of devices such as Windows, bitmaps, and printers. An object that wants to draw onto a device asks the device to create a graphics context object and receives a reference to the object's graphics interface. The graphics context stores the current drawing state, such as current font, background and foreground colors, etc. Anything that is used to render drawing operations onto the associated device. And then some related patterns to this are the facade factory method and mediator object patterns. The facade pattern uses a single intermediate object to hide the complexities of a framework of cooperating objects from the users of that framework. In contrast, the session pattern uses multiple intermediate objects to decouple objects that provide a service between servers and clients. The server object uses the factory method to create sessions for a client. This ensures that sessions can be initialized correctly by the server object. And then the mediator controls the interaction of multiple cooperating objects. The server object of the abstract session pattern can be viewed as a form of mediator controlling the interaction of all its clients. The session object can be viewed as simple mediators controlling the interactions of the server and a single client. Okay, so now we're going to talk about the session facade pattern. Similar motivation. This is a way to store sessions when a client is interacting with a server or database or making use of services provided. So what we like to do is discuss some of the background on this before we get into a use case or a class diagram and a sequence diagram. And it's very difficult to display coding examples because of the complexity of servers, the services that are implemented, and other things like that of that sort. So enterprise beans encapsulate the business logic and business data and expose their interface. Thus the complexity of the distributed services to the client tier. Some problems we'd like to solve. In a multi-tiered Java 2 platform Enterprise Edition application environment, the following problems arise. Tight coupling, which leads to direct dependence between clients and business objects. Too many method invocations between the client and the server, leading to network performance problems. A lack of uniform client access strategy, exposing business objects to misuse. A multi-tiered Java 2 application has numerous server-side objects that are implemented as enterprise beans. In addition, some other arbitrary objects may provide services, data, or both. These objects are collectively referred to as business objects, since they encapsulate business data and business logic. These applications implement business objects that provide processing services as session beans. Coarse-grained business objects that represent an object view of persistent storage and are shared by multiple users are usually implemented as entity beans. Application clients need to access business objects to fulfill their responsibilities and meet the user requirements. Clients can directly interact with these business objects because they expose their interfaces. When you expose business objects to the client must understand and be responsible for business data, object relationships, and must be able to handle the business data flow. However, direct interaction between the client and the business objects leads to tight coupling between the two. And such tight coupling makes the clients directly dependent on the implementation of the business objects. Direct dependence means that the client must represent and implement the complex interactions regarding business object lookups and creations, and must manage the relationships between the participating business objects, as well as understanding the responsibility of the transaction. As client requirements increase, the complexity of interactions between various business objects increases. The client grows larger and more complex to fulfill these requirements. The client becomes very susceptible to changes in the business object layer. In addition, the client is unnecessarily exposed to the underlying complexity of the system. Tight coupling between objects also results when objects manage their relationship within themselves. Often it is not clear where the relationship is managed. This leads to complex relationships between business objects and rigidity in the application. Such a lack of flexibility makes the application less manageable when changes are required. When accessing the enterprise beans, clients interact with remote objects. Network performance problems may result if a client object directly interacts with all the participating business objects. When invoking enterprise beans, every client invocation is potentially a remote method call. Each access to the business object is relatively fine-grained. As the number of method calls increase, the chattiness between the client and the server-side business objects increases. This may result in network performance degradation for the application. Because the volume of remote method calls increases the amount of interaction across the network layer. Another problem also arises when a client interacts directly with the business objects. Since the business objects are directly exposed to the clients, there is no unified strategy for accessing the business objects. Without such a uniform client access strategy, the business objects are exposed to clients and may reduce consistent usage. So we'll talk about some of the forces involved with this design pattern. We want to provide a simpler interface to the clients by hiding all the complex interactions between business components. We also want to reduce the number of business objects that are exposed to the client across the service layer over the network. We want to hide from the client the underlying interactions and interdependencies between business components. This provides better manageability, centralization of interactions, greater flexibility, and a greater ability to cope with changes. We also want to provide a uniform, coarse-grained service layer to separate the business object implementation from the business service abstraction. And we want to avoid exposing the underlying business objects directly to the client to keep tight coupling between the two tiers to a minimum. So our solution. We want to use a session bean as a facade to encapsulate the complexity of interactions between the business objects participating in a workflow. The session facade manages the business objects and provides a uniform, coarse-grained service access layer to the clients. The session facade also abstracts the underlying business object interactions and provides a service layer that exposes only the required interfaces. Thus, it hides from the client's view the complex interactions between the participants. The session facade manages the interaction between the business data and business service objects that just participate in the workflow, and it encapsulates the business logic associated with the work requirements. Thus, the session bean manages the relationship between the business objects. The session bean also manages the life cycle of these participants by creating, locating, modifying, and deleting them as required by the workflow. In a complex application, the session facade may delegate this lifestyle management to a separate object. For example, to manage the lifestyle of participant session and entity beans, the session facade may delegate that work to a service locator object. It is important to examine the relationship between business objects, as some relationships are transient, which means that the relationship is applicable only to the interaction or scenario. Others may be more permanent. Transient relationships are best modeled as workflow and facade, where the facade manages the relationship between the business objects. Permanent relationships between two business objects should be studied to determine which business object maintains the relationship. So here's a typical class diagram for this design pattern. And you'll see the client object, which represents the client in the session facade, which should only access the business service. This client can be another session bean in the same business tier or a business delegate in another tier. The session facade. This object is implemented as a session bean. The session facade manages the relationship between numerous business objects and provides a higher level of abstraction to the clients. The session facade offers a coarse-grained access to the participating business object represented by the invoke invocation to the session bean. The business object is a role object that facilitates applying different strategies, such as session beans, entity beans. A business object provides data or some service in the class diagram. The session facade interacts with multiple business objects instances to provide the service. And then the strategies. The session facade is a business tier controller object that controls the interactions between the client and the participants, business data, and business service objects. In a complex application, there may be numerous session facades that can intermediate between the client and these objects. You can identify where a session facade might be useful by studying the client requirements and interactions typically documented in use cases and scenarios. So here's a typical sequence diagram that you would see within this design pattern. So in every case here, you have the client accessing the session facade, and then the session facade is calling the corresponding object based on what the client wants to access, what service they want, what data they want, etc. The session facade is just that layer of abstraction and security in between the client in the underlying structure. So now we'll talk about some implementation strategies. We have the stateful session facade, and when implementing the session facade, you have to decide whether the facade session bean is a stateful or stateless session bean. A business process that needs only one method call to complete the service is a non-conversational business process. Such processes are suitably implemented using a stateless session bean. A careful study of the use cases and scenarios enables you to determine the definition or to determine the session facade definitions. If the use case is non-conversational, then the client initiates the use case using a single method in the session facade. When the method completes, the use case completes too. There is no need to save the conversational state between one method invocation and the next. In this scenario, the session facade can be implemented as a stateless session bean. Now there's the stateful session bean facade strategy. And this is when a business process needs multiple method calls to complete the service. And this is what we would call a conversational business process. The conversational state must be saved between each client method invocation. In this scenario, a stateful session bean may be a more suitable approach for implementing the session facade. In both stateless session facade and the stateful session facade strategies, the business object's role can be fulfilled in different ways. So if we talk about business object strategies, we can implement the object as a session bean, entity bean, DAO, or a regular Java object. So if we want to let's first talk about the session bean strategy. This is when the business object can be implemented as a session bean. This typically provides a business service, and in some cases could also provide business data. The entity bean is when the business object is the most typical representation in the session facade. When multiple entity beans participate in the same use case, it is not necessarily to expose all entity beans to the clients. Instead, the session facade can wrap these entity beans and provide a coarse-grained method to perform the required business function, thus hiding the complexity of the entity bean interactions. Then you have the data access object strategy, or DAO. And this is done when the application is so simple that it requires no entity beans, or when the application's architecture is based only on session beans and does not use entity beans. This application might need the services provided by an arbitrary Java object. In such cases, the session facade accesses this arbitrary Java object to provide the necessary functionality. Now I'll discuss the consequences of this design pattern. It introduces the business tier controller layer. Session facades can represent a control layer between clients and the business tier. A session facade encompasses the interactions between the client and the business components. In a sophisticated application, you may identify numerous session facades that can intermediate between the client and participating business tier objects. For simpler objects, one might feel that a session facade is not adding much value. But you'll see that as applications grow more complex over time, which hopefully happens if you build a successful application that a lot of people want to use, Using a session facade up front will benefit you later at a later stage. Hope for growth. And the other thing it does is it exposes a uniform interface. The underlying interactions between the business components can be very complex. A session facade pattern abstracts this complexity and presents the client a simpler interface that is easy to use and understand. By applying a session facade, you can design a service layer that exposes a simpler interface to the system as a whole. Thus, a facade provides a uniform, coarse-grained access layer to all types of clients and can protect and hide the underlying participating business components. This design pattern also reduces coupling and can increase manageability. It's best to use this pattern when you want to manage workflow among business objects rather than making the business objects aware of each other. A business object should only be responsible for its own data and logic management. Inter-business object interactions can be abstracted into a workflow and into a facade. Separating the workflow eliminates the direct dependency of a client on participating objects and promotes design flexibility. Although changes to participants may require changes in the session facade, centralizing the workflow in the facade makes such changes more manageable. You change only the client session facade rather than having to change all the clients. Client code is also simpler because it now delegates the workflow responsibility to the session facade. We also see performance improvement, and it reduces fine-grained methods. The session facade reduces network direct interactions between the client and business data and business service objects. All interactions are routed via the session facade in a coarse-grained manner. This session facade and its participants are closer to each other, making it more efficient for the facade to manage the interactions between the participating objects. All data transfer and method relatively high-speed network. The network performance can be further tuned to provide maximum performance. This pattern also provides coarse-grained access. A session facade is meant to be a highly coarse-grained abstraction of the workflow. Thus, it is not desirable to have one session facade per entity being at interaction, which would represent a fine-grained abstraction rather than a coarse-grained one. If you analyze the interaction between the client and the application services, you can determine the coarseness of your facade. You want to determine the optimal granularity of the session facade for the application by partitioning the application into logical subsystems and providing a session facade for each subsystem. It also centralizes security management. Security policies for the application can be managed at the session facade level, since this is the tier presented to clients. Because the session facade's coarse-grained access, it is easier and more manageable to define security policies at this level rather than at participating business component levels. Business components offer fine-grained control points. It is easier to manage security for session facade that provides coarse-grained access because there are relatively fewer coarse-grained methods to be securely managed. You also have control that's centralized for transactions. The facade offers a central place for managing and defining transaction control in a coarse-grained fashion. is much more work to do transaction management individually on participating business components. Also, not using a session facade, but rather having the client access the enterprise beans directly puts the transaction demarcation burden on the client and can produce unwanted results. You also expose fewer remote interfaces to the clients. The client can interact directly with the business data and business services, but this would increase chattiness between the client and server. And increased chattiness may degrade network performance. All access to the business objects should be through a higher level of abstraction represented by this facade. Since the facade provides a coarse-grained access mechanism to the business components, this reduces the number of components that are exposed to the clients. Thereby, the scope for the application degradation is reduced due to the limited number of interactions between the clients and session facades. So that was my presentation on the session state patterns.